valve and then it flows out. So take a couple of minutes to make sure you recognize all the ducts, and we will continue with the next page. What does the pancreas make? Many things. Pancreas produces a lot of enzymes and two hormones. What are the two hormones that regulate sugar, glucose? Insulin and glucagon. Okay. So all these accessory ducts. If you see the next page, can you see a structure with some cells, figure 25, 22, something that looks like this, right? You have the cells inside. We call them acinar cells. These are the ones that secrete most of the enzymes. We'll see what the enzymes are, the acinar cells. And inside, if you can see, you have the inactive enzymes. Can you see the zymogen granules? So you have everywhere. Okay. So the pancreatic juice will be released through these accessory ducts from all sides, then it will travel down the main pancreatic duct. And there are some more cells, I don't see it in that page, but if you don't mind, make a note. Some more cells that are scattered randomly. We call it pancreatic islets or islets of Langerhans, the guy who discovered that. These pancreatic islets, there are two kinds of cells. One is going to be alpha cells, one is going to be beta cells. The alpha cells produce glucagon, the beta cells produce insulin. So they are scattered randomly amongst those acinar cells. Wherever you see space, you'll find those two cells which together we call them pancreatic islets. Some are alpha cells, some are beta cells. One makes glucagon, one makes insulin. If you see A, B alphabetically, G comes first, I comes next, if that helps anyone. Which one makes what? Let's look inside the small intestine, page 976, figure 25, 25. You'll see like finger-like projections inside. Instead of rugae in the stomach, you'll see these projections inside the small intestine. So let's say that's your stomach, this is your small intestine. So anywhere you make a cut and look at the small intestines like this, you will see like rings inside, like a tube with the rings which we call circular fold. The membranous fold in the stomach was the rugae, right? That was a simple like elevation, depression. But here, the small intestine is arranged. If you look inside, it will be like a ring after ring. And you don't see that in the picture. What you see is this projection. These finger-like projections. So if you have these projections, so instead of the membranous folds, this is more pointed and like finger-like. It looks more like a toothbrush, the bristles. So what you have, the picture is a section of this. If you expand that, you will see like this. Right? So each one is going to be called a villus. Plural is villi. and you can see different cells that line the villi, right? Some of them are mucous cells. There is a absorptive cell which they call enterocyte. Then you can see the goblet cell. What does the goblet cell do? That's the mucus producing cell. Remember your columnar epithelium. And then you can see the there's one more absorptive cell where it says absorptive cell. The absorptive cell is going to be your enterocyte. Entero refers to the intestine. Cyte is the cell, like erythrocyte, leukocyte, right? And the goblet cell, as we know, secretes your mucus. Then they not only have the villi, on top of the villi it is further subdivided into finer hair-like structures which we call microvilli. So it's exactly like a toothbrush. If you take the toothbrush, what do you see? You have a bunch of bristles, right? And within that you see smaller ones, something like that. You have the villi, and within that microvilli. But why do we do that instead of having a plain smooth rugae like in the stomach? By doing this, you have more surface area, so you can absorb more nutrients. So the purpose of the modification of the small intestine into villi, structures like villi, is to increase the surface area for absorption of nutrients. Then within each villus you can see the blood vessels. You see the red, blue and green, right? Red is for the artery, blue is for the vein that comes to the small intestine. And the green takes away fat. They call it lacteal. That takes the fat for storage in the liver. Like we take glucose through the vein for storage, we also store the excess fat. Sometimes it's too much, it becomes fatty liver, right? You've heard of that. Alright, that's for the small intestine. Large intestine we already did, so we are good with the structures. Okay, so let's take